Your computer is sitting on your desk. Or maybe it is in your lap. It looks like a solid object. A screen, a keyboard, a box. But inside, it is a universe of electricity, moving at the speed of light, doing billions of things per second. But how? How does a machine made of metal and glass actually think? The answer is not magic. It is physics and logic. At the heart of every computer is the central processing unit, the CPU. You can think of it as the brain. But unlike your brain, which uses neurons and chemicals, the CPU uses transistors, tiny switches, so small that billions of them fit on a chip smaller than your fingernail. These transistors have only two states, on or off, 1 or 0. This is binary code, the language of computers. Every photo you see, every song you hear, every word you read on this screen, it is all just a long string of ones and zeros. But how do switches become a video game or a spreadsheet? It starts with input. You press a key on your keyboard. That key press is an electrical signal. It travels through the circuitry to the CPU. The CPU reads the signal, checks its instructions, says, okay, the user pressed the letter A. I need to display that on the screen. Then comes processing. The CPU fetches the instruction from memory. It decodes what needs to be done. Then it executes the command. This happens billions of times per second. Your computer is not thinking. It is calculating. Extremely fast. But the CPU cannot work alone. It needs memory. Random access memory. RAM. Think of RAM as your computer's short-term workspace. When you open a program, it loads into RAM. Why? Because RAM is fast. Much faster than your hard drive. The CPU grabs data from RAM, works on it, and sends it back. Then there is storage. Your hard drive, or solid-state drive. This is long-term memory. When you turn off the computer, RAM forgets everything. But storage keeps your files, your photos, your operating system. Finally, output. The CPU sends the processed data to your monitor. The monitor lights up specific pixels, red, green, blue, in combinations that create the image you see. This cycle, input, process, output, it happens constantly. While you watch this video, your computer is processing audio, decoding video, managing your internet connection, all at once. But who tells the CPU what to do? The software, the operating system, Windows, macOS, Linux. These are the managers. They decide which programs get access to the CPU, how much memory they can use, when to save data. Without software, hardware is just a brick. Without hardware, software is just text. They need each other. And here is the amazing part. All of this, the billions of transistors, the electrical signals, the binary code, it is all predictable, deterministic. If you put the same input in, you get the same output. Every time. That is why computers are reliable. That is why they can fly airplanes, run hospitals, power the internet. But they are not perfect. They can overheat. They can crash. They can get confused by bad code. Because ultimately, a computer is only as smart as the instructions it is given. So the next time you press the power button, remember what is happening. Electricity is flowing. Transistors are switching. Data is moving. A silent symphony of logic, playing out inside a metal box. You are not just using a machine. You are conducting an orchestra of electrons. If this breakdown helped you understand your computer, smash that like button. Subscribe for more tech deep dives. And tell me in the comments, what is the oldest computer you still own? The answer might be in your attic.